This is an example of structural analysis of a simply supported beam with one distributed load and 1 point force, and I will use Robot Structural Analysis program. In this example, the beam lengths are 4 and 2 meters, and the beam is 406 by 178 by 54 universal beam section. To do this example, I will create a new file, new project file, Frame 2D Design, and I shall start from the layout menu by placing the nodes. The grid and the ruler make it easy to place the nodes by just clicking on the screen. So the first one I'll put at 0, 0. Then the next one 4 meters, 4 and 2. That's all. Now I will go on to the sections materials and choose S275 steel, and I will also add the section UB 406 by 178 by 54. I have already chosen it, and add, and then close. Now with this chosen section I will create bars between the nodes. To zoom in and zoom out, the easiest way is to use the wheel on the mouse and press the wheel and drag to pan. Now the first beam, type beam, this is a cross section, is between nodes 1 and 2, second one between 2 and 3, and third between 3 and 4. The information is shown in the table and it can be edited from here. For example, the section can be changed or the node number. Now I'm going to set up the supports, and I have one pin support and one roller support. Now if the roller support is not showing, we can create it. So click on the new support, call it roller, and make sure the support direction is correct, and then click add. So that creates a new type of support, roller support, and this one is at point node 3. Now the only remaining task is to specify the load. That load 1 is includes the self-weight, and so I will create a live load to add the distributed load and the point force as defined in the example, and that can be done using the load definition tool. For the point load, in the node tab, I will add the load of -120. Add, and I will apply it to node 4, and in the bar I will apply load of -50, add and apply and close. Now these loads have their values showing now, and this is all needed before we can calculate by clicking on the calculator icon, and then display the results. The results that I will display are to show the parameter, the values of the shear force and bending moment. Need to click on the parameters, labels, and apply. And then in the NTM, I'll show first the for the live load, the shear force diagram. And this is the shear force diagram from the applied load on this beam. Moment diagram. The size can be increased, and it shows moments at all the nodes and also the maximum moment on the beam. And here we can see the maximum positive and negative moment from the live load. Now I can also find the maximum displacement, deformation, apply, and by default it will show displacement in millimeters, rounded, but we can change the accuracy in the tools. Displacement, maybe 2. So we are showing the displacements now in the scientific notation with 3 significant figures. And we can also see the displacements, maximum displacement here of the bar. The previous option were nodal displacements. I can also show the reactions. Vertical reactions and their descriptions. Vertical reaction 120 and 200. And stresses, bending stress. This shows the maximum bending stress on the beam, 258 megapascals above the support. And we can also show the shear stress, maximum shear stress, which is at the supports 43.6. 43.6 megapascals. And that is all about this example.